And so when we look at the sign changes here, we get what? 2. So 2 sign changes, so that's 2 negative zeros or what? Okay, or 0. 2 or 0. Okay, but we probably expect that there's going to be 2, right? Because we only have 1 positive 0. So we've got that. Now we'll come up with our list of possibilities. We're going to look at 10, which has factors of plus minus 1, plus minus 2, plus minus 5, plus minus 10, and then 3 with factors of plus minus 1, plus minus 3. Okay, so our list of possibilities is going to be plus minus 1, plus minus 2, plus minus 5, plus minus 10, plus minus 1/3, plus minus 2/3, plus minus 5/3, and plus minus 10/3. Okay, so that's our entire list of possibilities for real rational zeros. Okay, is there anything else that we can do before we start trying some of these out? We looked at the number of positive and negative. We know how many to expect. I think we're ready to go ahead and test some out. Okay, so I'm going to start at 1 and hope for the best. Or should we start at -1? Let's start at -1. Okay, so we get 3, 2, -15, and -10. Okay, so 3 and -1 is -3. We get -1. -1 and -1 is 1. -14, -14, and -1 is 14. We get 4. Okay, we didn't get a 0. We don't have any alternating pattern, so nothing there. So we'll try -2. Okay, so I'm sorry, I just went to lunch. Not sure why I did that. Okay, bring down the 3. 3 and -2 is -6. We get -4. -4 and -2 is 8. Gives us -7. -7 and -2 is 14. We get 4. So we still don't know anything. Should we try -5? Yes? Three and -5 is -15. We get -13. -13 and -5 gives me 65. Is that right? Okay, so that's the big number, 50. And then we get 250. Or is that -250? Which gives us -260. Okay. Do we know anything here? Okay, alternating. We had a -0 value that we're working on, -5. So there's no need for us to try -10. Okay. If we're going to have a value, then it's going to have to be one of our fractions. So what do you think we should try next? 1/3? Okay. Positive 1/3 or negative? Positive? Okay. All right, we're going all the way to the other side with positive values. -5 is a lower bound. Okay.
That means that that's the lowest number.
Well, there's not a 0 less than that. Okay. So that's why I'm not going to try -10. Okay. All right, so we got 1/3. We're going to look at 3, 2, -15, -10. Okay, bring down to 3. 3 and 1/3 is 1. So that gives me 3. 3 and 1/3 is 1. Gives me -14. -14 and 1/3 is -14 thirds. Okay, which gives me something, but it's not a 0. Okay, what else should we try? Okay, negative 2/3. All right, I'm going to bring down 3. 3 and negative 2/3 gives me negative 2. And 0. 0 and negative 2/3 is 0. Gives me negative 15. Negative 15 and negative 2/3 gives me 10. Very nice. And so we get 0. Okay. So what does that tell us? Now we can rewrite f of x as x plus 2/3 times, I think we started out with a cube, so we get 3x squared minus 15. Okay. And once we get to a quadratic, then we can use some of those other techniques to solve the problem. We don't necessarily have to go through well, we started with a cube, right? This was 3x cubed, x squared, x, and this was our constant. And then we divide it out by one linear factor. It goes down by 1 degree. Okay, so that's why we have now x squared. This would be x. This is my constant. Okay? All right, so our goal is to find the zeros. We got x equals negative 2/3, which we already had, and then 3x squared minus 15 equals 0. We could try solving that by saying 3x squared equals 15. X squared equals 5, or x equals plus or minus the square root of 5. And so those would be my 3 zeros. And we had how many negative ones? How many negative zeros? Well, we ended up with 2. And then we had 1 positive 0. Okay? Questions? Earlier we were using, the rule was we look at the number of sign changes. So when we look at the original function here, it only has 1 sign change. So that let me know that there would be 1 positive 0. Okay, and then to figure out how many negative zeros, we have to look at f of negative x. Okay, so f of negative x, we get negative 3x cubed plus 2x squared plus 15x minus 10. There's 1 sign change, 2 sign changes, so it would be 2, or it can differ by an even number. We just keep subtracting off 2 until we get to 1 or 0. Okay, so possibly 2 negative zeros. Okay, questions about that? All right, very good. I think maybe we got one more. Yes. Okay, I'm going to give you a little bit of time to start on this one on your own. Okay, how many positive zeros should we expect? Okay, 2 or 0. 2 or 0 positive zeros. This is positive, so we have 1 change and then 2 changes. Okay, so 2 or 0 positive zeros. As far as the negative ones, f of negative x equals 3x to the 4th plus 8x cubed minus 18x squared minus 40x plus 15. Okay, so how many changes here? Okay, 2 or 0. So 2 or 0 negative zeros. Okay, next thing we would do is come up with our list of possible rational zeros. Okay, my list was plus minus 1, plus minus 3, plus minus 5, plus minus 15, plus minus 1/3, and plus minus 5/3. Okay, everybody had this list? Okay, good. And then from there, we started working. We had the same number of positives as negatives, so I started with positive 1. Positive 1 did not work. Positive 2 did not work. Positive 3 did work. So we got 3, minus 8, minus 18, 40, 15. Bring down the 3. I get 9, which is 1. 1 and 3 is 3. I get negative 15. Negative 15 and 3 is negative 45. So we get minus 5. Minus 5 and 3 is minus 15. We get 0. Okay, so it worked. So once I did that, I was able to rewrite f of x as x minus 3 and then x cubed plus, or rather 3x cubed plus x squared minus 15x minus 5. Okay. And then, if we needed to, we could start a new list, which looks like it would have plus minus 1, plus minus 5, and plus minus 1/3 and plus minus 5/3. However, if we can break this down without doing that, then we should. And remember, the other day, no one asked me about this, but remember I tried to show you how to factor by grouping, and it didn't work, and we were supposed to come back and talk about it. So I looked at this, and I thought, this might work by factoring by grouping, and it did. So let me show you how we do that. Okay, when I look at these first two, I want to see what they have in common. They have what in common? Not a 3, just x squared. So if I factor off x squared, I'm left with 3x plus 1. And then the next two have what in common? 5. So I'm factoring off essentially minus 5. And I'm left with what? 3x plus 1. Okay, now I've got two terms. Here's one term. Here's the other term. And they have in common 3x plus 1. So we get x minus 3 times 3x plus 1 times x squared minus 5. And of course, a quadratic we should be able to solve without having to do the synthetic division. So we end up with x equals 3. And then we've got 3x plus 1 equals 0. So that gives us x equals what? Minus 1/3, which was in our list. And then we can say x squared equals 5, or x equals plus minus the square root of 5. And so we found 4 zeros.
The total cost
2 of
per
them
month
were rational
thousands
zeros.
of dollars
of
producing
all of them were real.
X printers.
We've
with
got
X
2 that
measured in
are
hundredths
positive,
given by C
and
of
then
X
2
equals
that are
X
negative.
cubed minus 15x squared plus 5x plus 50. How many units must be produced so that the total monthly cost is $125,000? Okay, we should be able to handle that. So we get C of X equals X cubed minus 15x squared plus 5x plus 50. And we want to set that equal to what? 125,000. We want to know this function gives us the cost of what? Producing X printers, or X hundredths of printers. So we want to know when the cost is equal to 125,000, or that's the same thing as saying x cubed minus 15x squared plus 5x
If we subtract 50, we get minus 124, 950 equals 0. And then what I think they want us to do is solve this. We're not going to do that. There's just way too many possibilities. So let's just go on. That's how we would set it up, you know, and if I asked you to do something like this on the test, I'd give you something that wouldn't have 1,000 possibilities, okay? We won't do that. Okay, very good.